Hello, everyone. I think this is a very special visit for me to Bangalore and to MSRI because I get to see half of my team for the first time. And thanks to the RF program that MSRI has run so successfully and that inspired me to have our own RFs as well. So when I was picking college, I had two options. Study electrical engineering at Kanpur, which would be closer to where my parents lived, or study computer science in a far-off city. I love programming, but I thought I could self-teach myself programming, and I really wanted to stay close to where my parents were, so the choice was clear. And in the first year of college, in an introductory programming course, our instructor told us that you can multiply two matrices using 7 multiplications instead of 8. So I was intrigued. I wondered how you can do that. At the time, there was no Google, much less ChatGPT. So I went back to the instructor and asked him, how do you do that? And his response was that this premium material is meant only for CS students while I was enrolled in the EE program. Upset at this, I rewrote the college entrance exam and got myself admitted in computer science in the same college, and even followed up with a PhD in computer science. And after I received my training as a scientist, one of the first problems I decided to study was how can you automatically synthesize such sophisticated algorithms? Perhaps by searching over the state space of all 10-line programs. It took me 5 years to finish my revenge. And the paper that we published described not only how you can synthesize this Strassen's matrix multiplication algorithm, but also many variants of it. And very recently, it also received the 10-year most influential paper award. But the main story follows. This is just the prologue. Once I was returning from a workshop on program synthesis, discussing these kinds of results. And there was a lady sitting next to me in the plane. She was very impressed to know that I work for Microsoft and that I have a PhD in computer science and I work on automated programming. So she thought perhaps I could help her with the problem that she was struggling with. She opens up her laptop, fires up Excel, and shows me a column of names and asks me, how can you reformat these names? Now, at that time, I had no idea about the programming model underneath Excel. So I had to sheepishly excuse myself out of the situation. After returning home, I searched for a solution to that problem on Excel help forums. And that's when I realized that there were many, many people who struggled with simple repetitive tasks like that of the airplane lady. And they would often communicate their intent to an expert on the help forum through input-output examples. And this is what inspired me to develop a feature called flash fill in Excel, which can automate such tasks from examples. So you fire flash fill by pressing Control E. And when you do that, it generalizes the example into a program and runs that program to automate your task. So this technology is based upon symbolic reasoning, logical reasoning, and is very compute efficient. So let me quickly show you some other scenarios that you can automate using flash fill. Here I have a bunch of medical billing codes, some of which have a right bracket at the end and some of which don't. Suppose you want to clean this data by adding a right bracket whenever it is missing. So if I give one example, flash fill comes up with the simplest generalization, which is to add a right bracket everywhere. Maybe this is what you want, and then you'll be done. But if you really want to clean it and have the right bracket only when it is missing, you can give one more example, say on row 8. And when I do that and hit enter, flash fill converges to the intent that I have in mind. Flash fill can do quite sophisticated string manipulation tasks. So here I am trying to compute an abbreviation, and just one example suffices. You can do lowercase, you can put periods, and it will all mostly work. So Flashfill works by searching over programs in an underlying domain-specific language. And then it finds many programs which are consistent with the example that the user has provided. But one of the magical ingredients it uses is to rank these programs and pick the top ranked program to present to the user. So let me illustrate to you the power of ranking on this last slide here. So what do you think I'm trying to do in column C1? Extract the first 3 letters. And what about in column C2? Extract the first 4 characters. And if you didn't see me operating in C1 and C2, what would be your most natural guess for what's happening in C3? It's the first word, right? Not the first 5 characters. And this is exactly what Flashfill thinks as well. But if you really wanted the first 5 characters, you can give one more example, and then Flashfill will give you that. And my favorite is this one, where I'm trying to compute initials. And one example suffices here as well. And Flashfill is smart enough to figure out that the lowercase a in v.a. comes from lowercasing of the initial of the last name, as opposed to, let's say, the second character or the second last character in Varun Agarwal. So Flashfill became a very popular feature. In fact, there were tons of videos and articles in many different languages that were written. I've even met people at airports and museums who have recognized me as the Flashfill creator and wanted my autograph. So I owe this celebrity status to the realization that science can actually bring joy to the masses. It is not just about solving an abstract or complicated problem, but it can also bring delightful disruption to people. I went from synthesizing complicated algorithms from logical specifications to synthesizing simple programs, but from input-output examples, something that many people would care about. In other words, I went from searching for the hardest problem I could solve to searching for simplest problems, but with most impact. And how do you go about finding such problems? Well, this is where I leverage building connection with customers and users. You know, it took me 3 weeks to develop the first implementation of Flashfill, but I had spent 3 months studying help forums to figure out the simplest problem with the most impact. And now one of my RFs, Ananya, is taking this line of investigations even forward, where she's developing machine learning techniques to actually even more efficiently study these help forums. I've spent months interviewing customers, doing nothing but just interviewing customers. I've analyzed telemetry data. And when you interact with customers, these people are not going to just tell you that this is what you should be building, but this is where you'll get to leverage your own creativity. And as Satya says, you need to cultivate empathy to grasp the unmet and unarticulated needs of these people. So Flashfill turned out to be the biggest turning point in my career. It gave me a different way to look at science. And my inspiration for this transition was actually my father. He would actually have been with me in this trip to Bangalore. Unfortunately, a few months ago, I lost him. I was lucky to take some of these pictures of him a few days before he passed away, in exactly the same spots that Microsoft had arranged a photo shoot for me to recognize some of my achievements, all of which I owe it to my dad. One of the first things I learned from him was grit. He lost his own father when he was just 4 years old. He would study under streetlights. He would tutor kids, some of whom were 2 grades higher than him. He had no money to pay for his college admission, yet he graduated as a civil engineer. And this determination to never give up is what I have found most useful in science. When everyone around me was telling me not to drop college and waste 1 year, it was my father who encouraged me to follow my passion in computer science. In fact, even annoyed with my audacity, my college later on decided to disallow people to even rewrite the college entrance exam once they've entered the college. And when my dad retired as a civil engineer, he wanted to become a better computer user. And even more than that, he was very interested in learning more about my research. And it is this curiosity of his that inspired me to pick problems that he could relate to. And we spend far too much time at work for it not to have deep meaning. The only way I rationalize the sacrifices of my family members for bearing the brunt of my absences is by my focus on building technologies that will affect their lives positively one day. And this is how my mind was prepared when I met the airplane lady and Flash will happen. And it became such a popular feature. But there are lots of tasks that Flash will cannot do. But the user experience is so inviting that people invariably want to give it a try and then talk about it when it does not work. It was not meant for date and number transformations, but only for syntactic string transformations. So a few years ago, this tweet went viral that someone wrote, "Look, AI is going to take over the world, but this is what Excel auto-populated for me today." Someone gave an example, DEC goes to December, and then Excel completes OCT to October. I also came across this shipping label where presumably someone incorporated Flashwheel as part of their process automation. So initially, I found this very embarrassing. But then I decided to take it in my stride. And we got it printed on our T-shirts. And sometimes I use this T-shirt for my keynotes. The real beautiful thing about this kind of customer feedback is that it tells you what are the next problems you should be working on. And that's exactly what we have done. And the new Flashwheel++ capability can now perform this sophisticated date, time, and number manipulations. So here I have a collection of a data set from emergency calls. And suppose my goal is to extract the red date and convert it into the corresponding weekday, and then extract the green time and convert it into a 3-hour bucket. Now just imagine how much code would it be and how much time it will take for you to do such drive column computations. But now we can do this with just one example. And not only that, Flashwheel++ also gives you readable code. In fact, this was the most asked feature from Flashwheel users because they want to look at this code for transparency and potentially even incorporate this as part of a bigger process. So Flashwheel++ can generate code in many different languages. Here you see it in Python. This code is fairly readable, has a lot of educational value as well. The first 2 lines tells you how to extract the red and the green substrings. The next 2 lines tell you how to cast it as a datetime object. The last line concatenates it all together. And it shows you that %A is the magic sequence of characters to use to convert a datetime object into the corresponding weekday. And this feature has recently been released and being slowly rolled out to more and more users in Excel Online. And it has also been released as part of Power Apps and Power Automate, which are other low-code languages at Microsoft. One of my favorite quotes from a customer was this, that it saved them 16 hours of work, just after 4 days of release. So my sister last year figured out that Flashwheel has even made it into grade 6 computing textbooks in India. And my dad was so proud of me. But I think there's a much bigger opportunity here. Flashwheel is a tool for completing the task for the user, but Flashwheel++ gives you readable code, which can be used as a tool for computational learning. It tells you how to do that task and how to precisely express that logic in different programming languages. So Flashfill made it into computing textbooks. And yes, it also got the 10-year most influential paper award. And I'm very humbled, for that. But my biggest reward here was what my dad told me. He used to cheer each and every research paper I got published. But it was after this paper, he told me that, son, now I understand your research for the first time. While it took the community to so many years to realize the importance of this, my dad immediately figured it out. And this is what inspired me to push more into this area. So let me show you what else can you do with programming by examples besides string transformations. Here I have a custom text file taken from a popular data science assignment. The instructor asked the students to take this and extract a CSV file out of it so that they can then analyze it and draw insights from it. The instructor provides the students a script to build on top of. Now let me show you the delightful experience that programming by example can offer for such tasks. So I've loaded the same file here. Suppose I want to extract the championship name. I give one example and then another one. And after this, the system is smart enough to learn a parsing script to be able to go and extract other instances of this field from the document. Suppose I want to extract the year. I give one example, and now the system can understand my intent right away. Suppose I want to extract the winning score, and this is what I get after one example. So there's an error in the third record because it is in a slightly different format. Now I can give one more example in the third record, and then the system will get it right. But what if this third record, which is in a different format, was somewhere deep in the middle of a big document? Now, if you're programming the task yourself, all bets are off. You'll have to figure out how to find such errors. But in case of programming by example, there's a fascinating thing that you can do. So you can take the multiple top-ranked programs, which are consistent with the yellow example that the user provided, and you can run all of them in parallel on the document. And then if you figure out some part of the document where these programs give different results, then you showcase that part of the document to the user. And if you do that on this is exactly what happens. And then the system asks you which of the following outputs you want. And I want neither, but it gives me the place to focus my attention on. And when I give this other example, the right example 16-7, it will converge to the right intent that I have in mind. So isn't this a very cool user experience? In fact, it is based on a paper that we wrote in 2010, which also received the 10-year most influential paper award. But when we even validated this problem definition with the customers by putting this on customer voice forums. So the lesson one was very much applied here. But when we approached the product team to consider shipping this thing out, they told us, we don't have time to build this user experience for you. Can you make this work with 0 examples? I thought they were crazy. But once I thought more about it, it made a lot of sense. If there are many tens of fields that you want to extract from a document, then giving 1 to 2 examples would be tedious. And in many cases, as a human being, when you look at a semi-structured document like on the top one, you can pretty much figure out what the various fields are. So we wondered, if a human can do this, can't a machine do this as well without any examples? And this led to some very foundational work on what we call predictive synthesis, which you can liken to zero-shot learning versus few-shot learning. And this in turn actually even went and improved the experiences with the by example modalities. And the experience that I showed you for text files can be applied to web pages, PDF documents, semi-structured spreadsheets, and so forth. In fact, Shriram, Arun, Suresh, have taken this even farther ahead by leveraging machine learning technologies to be able to extract data from heterogeneous documents. And Bhavya, RF on my team, is looking at many other data wrangling experiences as well. So many of these technologies that I describe here actually ship as part of data connectors in Power Query, and they have been quite popular. And recently, during the pandemic, one of the most heartening things was that they were used extensively to build dashboards for many COVID-19 datasets. So a lot of scientific progress happened in this area because of the discomfort that the engagement with the Power Query team created for us. And this brings me to my second learning, which is about science being a team sport. We are in an era where big scientific discoveries are unlikely to happen by a lone genius sitting in isolation. Today's disruptive science is a process of layering ideas, combining ideas, collaboration between big teams that not only provide the critical mass, but also bring diverse talent to the table. You folks may have heard about the murder mystery challenge. So they did an experiment where in one group were people who knew each other well, and in another group were people who did not know each other well. So in the first group, conversations were very fluent, but also lead to bias. In the second group, conversations were harder. There was a lot of conflict, but it led to better results. They were twice as likely to solve the challenge than the first group. And one question that arises is, how do you work well in a team with diverse talent? And one of the things that I've learned in life, a very important skill that you need, is listening. Now, if you have an idea and you go into a meeting, a typical tendency, at least my tendency, is to show, look how smart I am, and I hope you folks can rally behind me. Now, think about what happens, let's say, in a military meeting. When one presents the idea, then they ask for spears to be thrown at the idea, to poke holes into the idea. And why not? It's a life and death situation. Or think of a meeting between astronauts. When an astronaut presents an idea, they're specifically calling out, let's figure out all the ways that it can go wrong, and let's together make it better. I think that is the kind of mindset that we need in order to leverage the diversity of talent that might be there. And the other most important thing I've learned in my life to work well in a team is trust. And it does not happen overnight. You will trust day by day, person by person. One of the best stories that I heard here was after a week after my father passed away. And one of his friends came to me and told me a story that my father had told him, which I did not know before. So my father was tasked with renovating the residence of a new chief minister who had arrived. And the PA, the personal assistant, told my dad exactly how it needs to be done and what not to be done. And then when the chief minister saw the result, she was quite unhappy. She calls my dad and is quite upset. And at that time, my dad simply asks her, okay, so tell me, how would you rather like to have it instead? And when the PA later learned about it, that he was not thrown under the bus, he tells my dad that if you have ever have any bureaucratic issue, come to me and I will help you. So that was a good lesson for me as to how you can, one of the ways that you can, build trust with people. So moving on, so programming by examples can be applied not just for, data transformations, but also for code transformations. So here I have a bunch of edits in a code. These are about converting the expressions from centigrade to Fahrenheit. And these are quite repetitive edits in the sense that you can imagine a rule that can be written down to automate these kinds of edits, which is something that you can learn using Flashful for code kind of technology. So we also validated this problem because as developers, we know how common these kinds of repetitive tasks are. And we also did studies over commits to figure out that there were many such instances of these repetitive tasks. So lesson 1 applied. And then here is the first experience that we designed for providing this experience to the developers. We have 4 boxes. In the top left box, you copy paste all the expressions that you want to transform. In the bottom 2 boxes, you give me an input-output example. And then when you hit the magic button, you get the transformed expressions. Now, there's a very big problem with this kind of interface. So there's a lot of context switch that needs to be happening, a lot of copy paste. And then in the flow, user will not be able to remember to use your tool before they start doing this task. So this is what we learned from interacting with the Visual Studio team, which is my lesson number 2. And now let me show you the experience that we ended up designing to solve this problem. So this is spotted on this other t-shirt that I got, where we simply observe the user as they go about doing their edits. And then in this noisy sequence of keystrokes, we try to find examples of edits that can potentially be generalized. And then we apply this flash fill for code technology on these examples to produce these suggestions. So we developed this capability, we shipped it out, it started giving great suggestions, but also suggestions that were just plainly wrong. So for example, if a developer deleted 2 lines of code, it would sometimes return there to delete all lines of code. Some people, got unhappy. They started, tweeting about it, wanted to know how they can turn this off. And it started looking like as if it could become, clippy for code. And this forced us to very carefully look at the precision recall trade-off. And we were able to find the right balance by leveraging many extra signals from the user, such as where is the mouse or the diagnostic errors that were there. And then we did continuous improvements based upon what we found in the telemetry, what was working well, what was not working well, and so forth. And then Priyanshu and Yasharth, who are the RFs in the audience today, took this to the next level by even learning these edit rules across different users, not just in the session of one user. And it is all these continuous improvements that actually led to this feature being broadly adopted by more than 500K users. And today we are seeing upwards of 15 million suggestions accepted every month. And there are lots of happy tweets also there. This has also led to some fascinating follow-up work involving large language models, which Avishri and Aditya are leading together with several other people as well. And this technology evolution is the fastest that I have experienced in my career. Thanks to the research and its integration inside the product happening together at the same time. Which brings me to my third learning, which is about the importance of not only exploring research ideas, but also building their robust implementations. When I started my scientific career, I was fixated on generating lots of ideas, designing algorithms, proving theorems. Much like how my dad would involve me in many designs of the home that he built in Lucknow. But what I also remember was he depended on my mom and me to oversee the construction of the house while he would be posted in other cities. And that when that builder in me woke up, I realized the beauty of science and putting it together with robust implementations. So today I lead a blended research and engineering team where I try to nurture an inclusive environment for leveraging the skill sets and mindset of both researchers and engineers. Research is about embracing uncertainty, while engineering is about removing uncertainty. And when you bring these seemingly opposing values together, it leads to faster innovation. And once you build robust implementations, one of the powerful things you get is the agency to ship it out and take your innovation to real customers. But what was surprising to me in this journey was the other way around as well, because it puts you in a position to try out lots of ideas very quickly and filter out the winning ones. In fact, the most pleasant thing that I found was that process can actually even lead to more scientific and foundational innovation. So for instance, when my team found itself having to build robust implementations of many program synthesizers, it led to the science of a synthesizer for program synthesizers. So the key idea that I've shared with you up until now is about expressing intent using examples. But there are some tasks where natural language is a better way to express your intent. For example, suppose you want to take two pictures and combine them horizontally after adjusting their height and save it to the folder college reunion. So that was the last task that I held my dad with. And he really wanted to attend his college reunion in December. And he used this script to put together this family picture. A few weeks ago, I came across a beautifully written hand note from him where he had written down many how do I do X kind of questions, some of which I had answered for him, and he had even written down the answers, but some of which were left unanswered, for I often pretended to be too busy. That's why AI agents are the best. They're always available. And in fact, we had written many papers on programming using natural language. But one of the biggest challenges in this work was that these are very fragile technologies, could not handle the variability in natural language descriptions, and also were very domain specific. And now there's a happening advance in this area, the Copilot system designed by GitHub that can generate code suggestions from natural language for many different languages. I hope you all have gotten a chance to try it out. And if not, you should absolutely do that. It is based upon this large language model designed by OpenAI called Codex. But these models are not very precise. And they are also very expensive to run. So this provides a great opportunity for individual researchers who are not involved in the development of these large language models to take these experiences to the next level by building some interesting workflows around it to increase the precision, say by leveraging the domain knowledge, or by even fine-tuning these models and distilling these models down with some high quality data so that we can make them more cost effective. And moving on to the last segment of my talk, which is about yet another way to express your intent. So here you go about doing your task naturally, and then the AI agent helps you by giving you repair suggestions, much like how you would use AI for, let's say, editorial feedback. So let me motivate this by sharing with you an observation from an Excel help forum. So the Excel user wrote this formula and got this compiler error. Now, how many of you know how to fix this formula? Well, you folks are all like me. I also don't know because the compiler error message is not very helpful. Yes, and there are very few people like you, like the Excel help forum expert, who is able to figure out the intent of the user from this broken formula because it has most of the right ingredients, right? And if a expert can do this, we ask the question, can AI do this as well? And then I have Harshit here in the audience and Abhishek, who are looking at many different ways to do these kinds of repairs involving large language models. But the thing that I really want to talk about next and before closing is about a fascinating application area of repair. This relates to the sector that has not yet been disrupted by AI, education. So what you see here is not a stock picture, but taken by a colleague at Cornell in their intro programming course, the office hours of that course. The line extends around the corner. And you know what is the last student in the line thinking? Will I get those 5 minutes with the TA? The challenge with education is that even today, we are stuck with this centuries-old model where one teacher is teaching 30 students and she's not able to provide personalized feedback to the students. And especially in computer science, this problem is even worse. The demand for these courses is 5 times more than the capacity, and often due to lack of TAs. Another sad statistics is that there's an 80% dropout among US minority students, likely because they do not get the right help and the tech stack is quite inadequate. So I would like to put together a grand challenge of developing an AI bot that can give feedback to students by progressively revealing many hints, just like a human teaching assistant. And I feel that we are not very far off from realizing this dream. So first, we have seen tremendous advances in these large language models. And people are already talking about moving beyond banning ChatGPT into classrooms as to how we can redesign curriculum that can leverage this very powerful technology. Besides large language models, we also have the potential to leverage past student journeys. Students, year after year, from around the world, are collectively struggling with the same kinds of confusions that TAs try to help them with. This kind of data can be collected and be used to fine-tune these models. And then we have decades of advances in program analysis, verification. So we have some two gurus in the audience here, at least, Aditya and Shriram. And these powerful static analysis technologies can be used to provide a very high precision experience, which you would need in the classrooms. Now, if you would like to work on it, let's try to understand this from the lens of the 3 lessons that I shared with you. So to bring joy in the classrooms, you would really need to understand the pain points of students and teachers. And there is no better way to do this than just being a TA inside these classrooms. If you want to achieve disruptive impact, you should be working with a cross-disciplinary team. Machine learning researchers or researchers who understand these large language models, with symbolic reasoning and logical reasoning experts, so that we can build precise technologies. But the goal here is not to develop a system which can just simply solve the problems for students, but the goal is to augment their learning experiences. And for this, you'll also need to work together with HCI experts and pedagogy experts. And if you want to have a real impact, you want to deploy your solution in a real classroom and then iterate on it. And then what I also hope to do in this talk was to get you excited about my research area of AI-assisted programming. I talked about these 3 different ways to express intent. And I believe the future of programming is about taking it closer to human conversation, where we will need multimodality, combining these different forms of intent and also interactivity. So most of my initial work has been based upon symbolic reasoning techniques. And the recent advances in large language models is completely mind-blowing. I feel there's a new science waiting to be discovered by putting together the power of these 2 different complementary technologies. And programming is the most sophisticated artifact and tool that humankind has ever discovered. And I very strongly believe that it genuinely has the potential to empower everyone on the planet, including my dad, to accomplish more. Thank you.
Thank you, Sumit. So if there are any questions, I can move the mic around.
Yeah, thank you, Sumit, for the great talk. So you emphasize the importance of connecting with users and bringing these technologies to users. large language models seem to be like uncannily good at discovering user intent, and they seem to have like really big potential in this field. So I just wanted to ask you, what do you see as like the biggest shortcoming of these models with your interaction with them so far? And maybe how do you see like the symbolic techniques that you've explored in the past decade or two fitting into how LLMs might help users in the sorts of tasks you've described?
So that's a great question. And the observation that I will lead with is that these technologies are actually foundational models which are supposed to serve many different domains. And our opportunity would be to build better solutions for specific domains by leveraging the domain insights. So one such ingredient would be even as simple as high quality data from that domain that you can use to, say, fine tune these models. So the paper that they put out for ChatGPT and how it compares with the predecessor model describes their efforts in hiring 40 contractors to label high quality data. And what they show is that with this data, they are able to build a model that is 100 times smaller and better. And they also provide this note that domain experts can potentially repeat this exercise for their domains by figuring out a way to get high quality data in that domain. So that I would say is one, which is fine tuning and specializing it to the given domain. Another would be to improve the precision of these models further by leveraging symbolic techniques. And this would come in the form of what is being called pre-processing as well as post-processing. So on the pre-processing side, you can think of the prompts as the new form of programming. And you can be very creative what you put inside these prompts. Like one very fascinating idea that was recently figured out was, it's called, probably you might have heard about it, is this chain of thought prompting. And it shows that these models can apparently even learn to reason as well if you ask them to show the work instead of just producing the answer. And then there's a potential of doing some post-processing on the results. For instance, if the output of the model should satisfy some kinds of syntactic and semantic constraints, but it is not, you can think of it as a repair task. So we actually wrote a paper called Synchromesh on it. And then Shriram has been involved in some very fascinating work in this space. They have a project called Jigsaw, which can be used to, so where the idea is that you see the kind of mistake that the model is making, see how the human fixes it. And then in the future, if you get a similar mistake, can you use those learnings from the past to automatically repair the output? So pre-processing, post-processing, fine-tuning would be the ways to improve the precision. The other question to ask would be, how do you reduce the cost of these kinds of models? And this is where I believe that some of the work that we have, which does not leverage language models, will still be useful, because you can imagine a waterfall kind of model where if you have to solve simple instances of tasks, you first use the cheaper techniques, and when they fail to produce the results, then you pass it over to more of these expensive models. Maybe I'll probably stop here, but I feel that there are a lot of opportunities for individual researchers like us, who are not involved in these large language models, to be able to make them more precise, to reduce the cost, and also to make them more personalized in different settings.
Got it. Thanks a lot.
Yeah. Okay.
So we have a question online. So Pratyush, please go ahead.
Yeah, thanks, Aditya. Thanks, Sumit. Really enjoyed listening to your story and the valuable lessons that you have put here, especially resonate to the last one, right? It's important to build and learn from that process. One thing I found characteristic in what you have done is your deep connect with users, right? And what they find valuable, especially the simple UI of flash fill, right? You just type something and then enter, and the rest of it populates. In the LLM era, where people are talking about language, natural language as the next programming language, do you have a sense of what that user need is, right? As in, is the Copilot thing the right thing, or are there other interfaces that people might be wanting? Some of it we have to imagine, but just wondering from your deep connect with users, if you have an insight on how these things would play out.
So again, great question. And maybe if I were to just slightly, rephrase that, it would be, and please correct me, if I'm wrong, is natural language the ultimate, future UI, or do we also need to take into account, other modalities? And Bhavi, I know this will be relevant as you, study users as well, and specifically in the context, data wrangling. And my initial, hypothesis would be that there are different ways to express intent, and in different settings, different modalities would be more natural. So we should think, what is happening right now is that there's a lot of interest in natural language, and for the right reasons, because this is a very important modality, and people had tried to build solutions for long, which happen to be fragile and very domain specific. But at the same time, there are places where we need to look beyond as well. So for example, if you are interacting with a rich application, you might be using lots of user interactions within the application. You're clicking on things, your mouse movements, and so on. And if you want the system to be able to guess your next step, you don't want to express your intent in natural language or voice at the time. You want the system to be smart enough to figure out what kinds of interactions you are doing within that application in the past, and be able to help you with what might come next. So this is what I would call is the modality that we have in IntelliCode suggestions, which is a feature we ship within Visual Studio, as opposed to, let's say, the Copilot experience. In Copilot, you describe what you want in natural language, versus in IntelliCode suggestions, we just watch what you have been doing naturally and then give you suggestions going forward. So that's one fundamental modality. Input-output examples is another important modality, especially in many drive column settings. Still, examples might be a crisper way for you to express your intent as opposed to natural language. In some cases, you might want to even combine the two together, because examples are also ambiguous. Natural language is also ambiguous, but perhaps the ambiguity actually cancels out. And this is what I've been referring to as multimodality on this last slide as well. So examples, natural language, being able to predict what comes next from having observed what you have been doing in the past. And another one is repair, where we just let you do the task and then the system helps you. So for example, let's say, you don't ask ChatGPT to write an essay for you, but you want to exercise your own creative writing. You have your own ideas, very unique ideas, but to write it down in a flowery language that you want would also take some time. And this is the mundane part of your job, of a journalist maybe, which can be automated. So that part, but the initial part of the creativity as to what are the key ideas of the content and so on are still yours. And I would put that more as a repair kind of category, where you precisely stroke out the top key level ideas, your insights of what you want your program to do or what you want your essay to be about. And then the system comes in and repairs, for it. So my thinking at this point is that we should look at these different kinds of user experiences, some of which we will find, LLM as the key building block. And for some of them, we might figure out that other technologies might be a better fit. I've tried to do some flash fill tasks using ChatGPT. What I figured out was that if I ask it to map Sumit Gulwani to S.G. It still does not give me the right result. It's close, but it's not correct. I tried G.S. and few different variations. It was, all wrong. But when I ask it to convert John Smith into J.S., it works. Apparently, it's a more common name. So this is what I will say, right? There are different modalities of intent, and user studies, help us identify these things.
Thanks, Sumit. That's helpful. Thank you.
Provocative talk, especially the last part about programming and stuff. I think I should be audible. Hello. Yeah. So this part about the programming course had me thinking. if you recall, open book exams were brought in to prevent mugging up and answering questions, right? And you had to change the test to fit an open book exam. So I'm wondering if you want to disrupt introductory programming course with ChatGPT available to the students, how would you teach it? And what is the intent of a programming course, introductory programming course? To be able to present an idea and create code, but somebody's generating the code. So what would you teach if you take away the mechanics of writing? My suggestion to you is maybe if you run a course, you will find the user interactions that you are looking for. The user studies as to what do the students do and what do they learn? What is the outcome of such a course? Very interesting. I mean, I'm just speculating based on you said change education, change programming, language courses. The introductory courses is 200 people. The outcome is usually a small segment of code input out of examples, which you pass, you get an A. But with ChatGPT, what are they going to learn?
So Manohar, that's a fascinating question, and I do not know the answer to this question. But the very important thing is that you are starting to ask this question, and that's the most important thing at this point right now. There were some school districts and some colleges that initially had a knee-jerk reaction, which is to ban use of ChatGPT. And then I recently saw some announcement where the dean instructs all the professors to start using ChatGPT, understand its strengths and weaknesses, and redesign the curriculum. That is the thinking that we need right now, much to what you are saying. One of the things that we are inspired to do in the intro programming classroom is to integrate ChatGPT in the editor and let the students ask any kinds of questions as they are trying to work out their programming assignment, and be able to look at the data and see what kinds of questions they're asking. Where are they still struggling from the response, or what has been very helpful? Maybe that will probably show us something. So we don't do this in the classroom, in the exams first, but we provide them this capability to work out their assignments in a lab, but everything gets recorded so that we are able to then analyze the data. Maybe looking at the calculator analogy may teach us something, which is that we still realize the importance of teaching students addition, multiplication, and even when calculators are at homes and so on, they can be brought into the classrooms. We have gotten a discipline to first teach them the fundamentals and then move on to the part where the presence of calculator is actually assumed. Maybe I'll share a different story related to my own child. It was not about programming as much, but it is about in the context of language learning. So he's in 4th grade, and he comes to me one evening saying, every parent is helping every other child to prepare for this amazing reading competition, and you're not helping me. Can you please help me? So I asked him, what does this entail? So he said, I've been assigned some books to read, and then you should ask me some intelligent questions of the book. Now he's giving me a 200-page book that I've never read. I take out my phone, ask ChatGPT, have you heard about this book? It says yes. I ask my son to come into my room in 5 minutes. He comes, and I start asking him intelligent questions. And after a few iterations, he grows suspicious and then comes and looks at my monitor and asks me, aha, so you are chatting with a friend who has read this book. And then, there's also a question that he answers wrong because ChatGPT is telling me that this is not the answer. I challenge him again. He insists, no, he's correct. And then he just opens the book and shows me. So this is a great demonstration of a technology being used to improve educational experiences, even when it is not perfect. When I asked him to use this technology to work out some of the other assignments he had, he clearly told me, no, that would be cheating. I won't do that. So I was pleasantly surprised at his maturity level in grade 4 to be able to figure out when he wants to use it or not. He did use it somewhere else. And then what we decided was he's going to acknowledge that he actually used this tool. Manohar, what I'm really worried about is that this tool will now be in the hands of students. And education is the thing that is going to be disrupted the most. And what is very, very important is for us to act and act fast to ensure that it brings the kids, this technology is being used to bring the kids at level playing field as opposed to the inequality being increased. So all people, privileged folks will get access to this technology. Kids will be using it. In India, someone was telling me, Varun actually was telling me that there are 8th grade kids who don't even have the readiness of 3rd grade. So we also have to start thinking about how do we uplift the experiences of these people. So the potential is there, the technology is there, probably it has arrived faster than it should have, right? The cat is out of the bag right now. And the importance is on people like us who understand these domains, who are passionate about these domains, to take the lead and think and build the right experience. So I do not have the answer to your question about what is the right experience, but I'm so glad that you are thinking about it.
Sumit, I have 2 questions. One of them is that every time that there is actually a big leap in the level of abstraction that people used to program, right? We went from assembly to higher level languages and so on. And then that maybe a lot of people got scared of saying actually the people who do assembly won't have jobs anymore because compilers are there. Then we saw a large number of programmers. The number of programmers just increased significantly. My question is actually, because of this revolution, what do you think will be the next set of programmers, and what will they do? That's one question. Then I have another one, more technical one, but I would love to hear your views on that. This one first.
So as you kind of give the answer in your question itself, Shriram, that the level of abstraction is going to be raised, and what this means is that these people will now be more productive, probably even more satisfied in their jobs, because now they can focus on the creative parts of programming as opposed to 80 or 90% part which goes into more mundane software maintenance kind of tasks. And now we empower people to take on the real challenges, the problems that our planet faces. So that is the way I would probably look at it, right? So by making them super productive, they are able to now use more of their focus more on their creative aspects and solve bigger challenges. And on a more practical level, I think what this probably also means is that now those organizations, smaller organizations, the complete opposite of big tech companies, will now be able to probably take on projects which they could not before, because now maybe they don't need 10 software engineers to accomplish and realize their dreams. Maybe banks will now be able to afford a smaller team of software engineers to be able to bring automation that has been long pending. So that in my mind is one of the big disruptions that will also probably happen. Even this last week, I was talking to someone who is in a very different kind of space, legal space, and he has figured out many things that should potentially be automated, but he's always been daunted by how should he go about it and setting up a big team and so on. I think one of the real empowerment that we are providing is to those people to be able to bring their creativity to life, right?
So now I'll ask my technical question. My technical question is, since like many of us here, you work on both machine learning and these sort of symbolic methods, how do you see that combination going? In the sense that, do you think the main flow of control will be with an LLM and the LLM will invoke symbolic methods on demand? Or do you think the symbolic methods will be the main flow of control and they will invoke the LLM on demands? Or will both things happen?
Both. And in fact, there are also applications where, let's say we are trying to generate some suggestions for how do users or data scientists want to clean the data before they can start building ML models on data. This is a place where apparently data scientists are spending 80% of time. So what we observe is that there are some suggestions for data cleaning, which only those symbolic techniques can generate, which can actually scan over large amounts of data that you have to figure out the corner cases and where the values are missing and where the data is in slightly different format. This is something that LLMs just cannot cleanly do because you cannot feed in this amount of data inside the LLM. On the other hand, we are seeing that there are some amazing semantic suggestions which the LLM can offer, such as related to feature engineering, where they suggest what features you want to create. So this is a case where the same experience is being powered by two technologies which are completely working in parallel. But then to your point, Shriram, there are cases, especially around NL2 code, where LLM is the driver, and then the role of symbolic machinery may potentially be in doing the right prompt engineering for personalization or doing some bits of repair to improve the precision. But it will also be a moving target because the power of these models continues to increase, and we are not yet seeing the ceiling, anywhere. And on the other hand, my favorite example where the symbolic techniques, takes the lead and LLM, serves is probably still, again, I might be wrong, things might change, is programming by examples, where I gave you these simple scenarios of programming by example transformations, which LLM I have not yet seen is being able to do. But LLM can do something very beautiful in that setting. It is able to give you an explanation of the code that we synthesize. That explanation is sometimes slightly buggy, and we can have a potential to even repair that explanation. And this is very useful when the code is being generated by AI, and now you want to get confidence into what this code is doing. So you also want to generate some explanations. So basically all of the above you said, but also a parallel model. And one more, I'm also reminded of one other thing now that I say this, of what you might want to consider teaching in classrooms. Maybe debugging is going to become an important topic now, because if the humans express the creative ideas, the machine tries to automate it. But then if there are going to be some errors, then we need people to quickly figure out what the errors might be.
Okay, so we are out of time, but we can continue this conversation with Sumit offline. So let us thank Sumit once again for sharing